Here it is in all of its glory, x squared. If you put in a 2, what's the output? Yeah, you know what the output is, right? It's not like, it's maybe this. No, you input a 2 into the function, you know the output's 4. What if I input a negative 2? Yeah, you know what the output is, okay? Now what an inverse function is you literally flip the inputs and outputs. The inputs become the outputs become the inputs. If I wanted to look at the equation, what you would literally do, since this is your input, Roxana, and this is your output, you just flip every single point. If you flipped every point, this graph would look like this. This would be the graph of x equals y squared. And it'd be that, which is fine. You're going to deal with these things this year. It's a sideways parabola. Again, here's the point 4, 2, and here's the point 4, negative 2. Do you see it? And every other, here's the point 0, 0, 1, 1. Instead of, 1, negative 1, or negative 1, 1, and 1, 1, it's 1, negative 1, and 1, 1. Every point is just flipped. That's what an inverse function is. The inputs are the outputs, and the outputs are the inputs. The x's are the y, and the y are the x's. Now, we're going to deal with this thing, and he's going to be fine, but however, there's a problem with this in terms of functions. What's the problem? It's not a function. Why is it not a function? Yeah. If I input a 4, I don't know what output I want. Does that make sense? So it's fine. This is called a relation. It's just not a function. And what we're talking about here with one-to-one function, each output value of a function is associated with exactly one input value, passes horizontal line test. What that means is, if you have a function passes vertical line test. If you want to know that its inverse is indeed a function, it has to also pass horizontal line test. And this one, as you can see, fails it. You see, if you put a horizontal line through, it's going to knock the graph twice. Does that make sense, Chris? Okay? And then, because you can see, if you did flip it, this does fail vertical line test. Okay? So if you want to know if a specific function is one-to-one, what that means is it doesn't have an inverse function. It has to not only pass the vertical line test, also the horizontal line test. Okay? How are we feeling so far? Yeah? Good? Sneeze? So good we sneeze. Good. Alright, so here's the notation for inverse function. It's f to the negative 1. That doesn't mean flip it. You know what I'm saying? That doesn't mean 1 over f of x. You know what I'm saying? What it means is the outputs became the inputs became the outputs. A good example, I want everyone to take their calculator out, make sure you're in mode degrees, and just put sine of 30 degrees. And what do you get? 0.5. What that means is, from the 30-degree angle from a right triangle, the opposite to hypotenuse proportion is always 0.5. Okay? Does that make sense? You input the angle and it outputs the proportion. Well, what if you hit inverse sine or second sine of 0.5? What do you get? Is it 1 over? Is it 1 over? You know what I'm saying? Like, it's none of that. What you just did is, what inverse sine is, you give me the proportion, I'll give you the angle. Does that make sense? The inputs are now the proportions, the outputs are the angle. That's what an inverse function is. You literally just flip inputs and outputs. How are we feeling with that? Is that alright, guys? Yeah? Okay. So here's a couple other examples. F of x equals 3x, which is y equals 3x. You just flip, literally, algebraically, you can just flip the x's and the y's. And then you would back solve for y. So when we did that, we found that y equals 1/3 x. Or the inverse function of f is equal to 1/3 x. Okay? Does that make sense?
Can you repeat that?
Yeah. What we did here on the left example is we started with the line y equals 3x. We flipped the x's and the y's. And then we resolved for y. When we do that, you actually solve. It's a process to solve for the inverse function. Okay? And then we would write it, instead of y equals 1/3 x, as f inverse x, meaning the inverse function of x is equal to that 1/3 x. Okay? If we look over to the right, this g of x equals x cubed. Same process, y equals x cubed. You flip the x's and the y's, and then you back solve for y, and we get x equals x to the 1/3. Or the inverse function of g is x to the 1/3. So those are two inverse functions of the originals. Okay? That's how you do it algebraically. If you want to test that the two functions are inverses, you do the composition. You stick one into the other. And since they're inverses, it doesn't matter which one you do first, because they're inverses of each other. Does that make sense? So you stick one into the other, and if you get x back, those are inverses. I took, on the left one, I took the 1/3 x function and dumped it into 3x. So I took the x out, put 1/3 x in, and I got x. Those are inverses of each other. On the right, I took out x in the x cubed function, I put x to the 1/3, exponents raised to exponents, I multiplied them, and I get x. Those two functions are inverses of each other. Okay? Now, geometrically or graphically, what that means is they're symmetric about the line y equals x. And we're going to do that in a second. For example, the one on the right was x cubed and x to the 1/3. Here's x cubed. There's x cubed. If I wanted to graph x to the 1/3, it's going to look something like this. Graphically, all inverse functions are symmetric about the line y equals x. Since you literally flip your x's and y's, they're going to be symmetric about that line y equals x. Okay? Instead of solving for all of this stuff algebraically or looking at a picture, what you can do actually, if you're in parametric mode, there's a really easy way to look at the inverse of a graph. So ever go back to parametric mode, and on your x1, y1, put in t and t cubed. And wouldn't that make sense? Wayman, that if you took that, this, for t, that is x cubed. Does that make sense? So put that in your x1 and y1. And check your window. Make sure your window is something like, your t counts for a little bit, and your x's are good, and your y's are good. And if it's all screwy, just talk to the person next to you about how to fix that window. But make sure you're in mode parametric, and on x1 is t, and on y1 is t cubed. Okay? And if you're having problems with the graph, again, talk to the person next to you. Parametric mode, if x is t and y is t cubed, an inverse function literally means just flip the inputs and outputs. Well, you can easily do that in parametric mode. On x2, if you put x2 as t cubed and y2 as t, you just flip the x and the y values. If you did that on x2 and y2, you'll see the inverse graph without having to do it algebraically. Try it. Does that make sense, Eric? Okay, good. Yeah. Talk to Anna. See what's going on. I like the honesty right here. It's good. How to explain log. A log is, the only thing it is, it's the inverse of an exponential function. If I give you the exponential function y equals 2 to the x, okay, if I put a 0 in, what's the output? 1. If I put a 1 in, 2. What if I put like a 3 in? 8. Does that make sense, you guys? Exponential function, you input into the variable, and you... What's that? Yeah, no, it's all good. And you output the value. What a log is, it's just the exact opposite. It's the game. Again, it's the CDD party. You try to figure out the exponent. They'll turn one into the other. Is it 7? Oh, you owe me some Pringles. That's what we do. Okay? Alright, so here's how you write it. You'd write it something like this. Log base 2/8. And here's the game. It's like, you go spinner. It's like, okay, it landed on Marco. Marco, what? 2 raised to what equals 8? You did it! You did it!